4.3 Vectors Review by me, Anna Dannecker. The learning intentions for this lesson: we are learning to use and construct vector equations in 2 and 3 dimensions, and we are also learning how to calculate the angle between two lines. We will know we are successful when we can complete 2 IB questions correctly. So, some fast facts for review. A vector is written in component form 3/1 for a 2D vector, or insert any numbers, or in component form 3/2 for a 3D vector. The top number shows a change in the x-axis, the next number shows a change in the y, and for 3D vectors, it shows the change in the z-axis. We also need to know scalar or dot product, which is found using the equation dot product of v and w equals v1 times w1 plus v2 times w2 plus v3 times w3, but I decided to use O for the example because calculus. And we need to know the equation for magnitude, which the symbol actually looks like absolute value bars, but they're not. So for this, it's finding the magnitude of vector w, and that is equal to the square root of w1 squared plus w2 squared plus w3 squared. Now on to important lesson concepts. The vector equation of a line is r equals a plus t times b, where r is the line, a is the initial position, and it's a vector. So in component form, this would be vector a1, a2, and t is the scalar multiple, and b is the direction vector. So how does this equation work? Where is it derived from? So in this example, we want to write the equation of the line, which is shown here in purple, that goes through point D in the direction of B, which is in blue. So we can say that for our equation's purposes, we want to have initial position, and since it's going to go through point D in the direction of B, we also have a position vector, lowercase d, which you can see to the left of point D, so we'll use that as our initial position in the equation. And then we also have another point on the line that D is going towards, so we can make vector dg, which is in the same direction or parallel to B. So vector dg equals t, the scalar multiple, times b. And that would be, so t times b would be our direction vector. So then I plug that information into the equation in orange to get g, which is the vector og, which touches g on the purple line, equals d plus t times b. Another important lesson concept: the equation for the acute angle between two lines. It is cosine theta equals the absolute value of b1 dot product b2 divided by the magnitude of b1 times the magnitude of b2. And b1 and b2 are direction vectors, which we can find in vector equations of a line, which we just learned about. And if a question doesn't specify if it needs to find an acute angle or obtuse angle, for our purposes it will always be acute unless it specifically says obtuse. And if you ever need to find an obtuse angle, you would use this equation and then subtract the answer from 180. Okay, so let's use our knowledge in an example. Find the vector equation of the line through the points a, 7, negative 7, 2, and d, 18, 3, negative 1. So we're going to use the equation r equals a plus t times b. So we can choose either of the points to be the initial point or the initial position. And I chose point A, and I wrote it as a vector, so in component form, vector 7, negative 7, 2. And then to find the direction vector, since I chose initial position of A, then it would be going towards D, so we want to find vector AD. And we know from previous lessons that to find that we just need to subtract A from D. So that's 18 minus 7 equals 9, 3 minus negative 7 is 10, and negative 1 minus 2 equals negative 3. So in component form, the direction vector is 9, 10, negative 3. And then you can just plug all that information into the equation. So R equals, in component form, the vector 7, negative 7, 2, plus T times, in component form, vector 9, 10, negative 3. Example 2. Given line 1, R1 equals 16I minus 2J plus 3K plus T times 3I minus 6J plus 2K. And line 2, R2 equals 13I plus J minus K plus S times negative I plus 7J minus 4K. Find the angle between these two lines. Okay, so it looks pretty crazy right now, but that's just because the lines are written in unit vector form, but we can easily write them into component form our equation asks for. So for the first line, instead of writing 16I minus 2j plus 3k, we can write in component form vector 16, negative 2, 3, plus t times, in component form, vector 3, negative 6, 2. And we can do the same thing for the second line. So R2 equals, in component form, vector 13, 1, negative 1, plus s times, in component form, vector negative 1, 7, negative 4. And then we can start plugging things into our equation. So we really want the direction vectors, so b1 and b2, which I've circled to the right in red. And first we'll find their dot product. So that is b1 dot product b2 equals 3 times negative 1 plus negative 6 times 7 plus 2 times negative 4 equals negative 53. And since the equation asks for absolute value of dot product, negative 53 ends up just being 53. Focus on solving the denominator. So that's the magnitude of the first direction vector times the magnitude of the second direction vector, which you can see here. So to find the magnitude of the first direction vector, we define the square root of 3 squared minus 6 squared plus 2 squared, which is equal to square root of 49, which is equal to 7. And for the second direction vector, we can plug in our numbers to get negative 1 squared plus 7 squared minus 4 squared equals the square root of 66. And then putting this all together in the final equation, cosine theta equals 53 divided by 7 times the square root of 7 times the square root of 66. And then to find theta, because we want an angle, that's what the question was originally asking for, we find inverse cosine of both sides to cancel out cosine on the left-hand side. And plug that into your calculator. And you'll get that theta equals approximately 21.3 degrees. So here are your two IB practice problems. They have several parts to them, but they're very repetitive. I thought it would be good practice for these concepts. Zoom out a little bit. And here are the answers. have fun working on those problems. I hope your video went well. I hope you liked this one. And thank you for watching Cal Math Production. Copyright 2016. Good luck on exams.